in are what's called the comparison test. There's two of them. There's one called the direct comparison test, and I've put over here a list of the questions that would be the appropriate test to use. And there's another one called the limit comparison test, and I've put over here the ones that that test would be used. Technically speaking, you can use, in many cases, not all of them, you could use either method, right? So for some of these questions, they could be over here, right? For some of them, not all of them. If you can do it with limit comparison test, you can always do it with a direct comparison test. If you can only do some direct comparison tests with limit, so it's not a two-way street, right? Okay, so let's remind you on the first one, because that's the one I'm going to focus on first, and then we'll move over to the other technique. Let's look at the limit comparison test. So essentially what it says is, suppose you are interested, already screwed up there. Suppose you're interested in a series, sigma AN. Then what you do is you find a comparison series, which is basically a series, a much simpler series that is equivalent, at least in structure, to the original, and we tend to call that guy sigma Bn. This series tends to fall into two major groups. It's either going to be some P series or it's going to be some geometric series. So anyway, so you take your original and you find a comparison to it, and it's either a P series or a geometric series, and then you'd find this fella. You find the limit as n tends to infinity of 1 divided by the other, and it will equal L. And as long as L is a number, and it's not allowed to be 0, and it's not allowed to be infinity, right? So as long as it's 5 or 3/4, as long as it's a number, then your series behaves just like the comparison. So if the comparison diverges, so will the original. If the comparison converges, so will be the original, right? So that's kind of how that strategy works. So you don't really answer the question directly. You don't find, does that converge directly? What you do is you find somebody who looks like them, but it's easier, that you know converges or diverges. And then you prove this. And this bit here is just to make sure that you haven't chosen a bad comparison. I think at the end of yesterday, didn't I choose a bad comparison and got the limit infinity? If you get a 0 or infinity, that's not the guy. Find somebody else, right? Or find some other technique, right? That's not the one that's going to work. So I think the best thing to do in these questions is find some and do them. Practice makes perfect. So let's see what question 6 looks like, because I picked that one, right? The guy that we are going to do in question 6 is that guy, right? That's my sigma AN. Okay, now I need to find a sigma Bn. I need to find somebody similar looking to that guy, but much simpler. Would you agree that this guy is probably related to a geometric series? You agree? This guy's probably related to a geometric series, okay? So who would be the simplest version of him? Well, how about 7 over n to 9 over n? Would you agree it would behave like that? I call that surgery, right? Where you basically throw away bits that you think aren't that important, right? Would you agree that 9 to the power of a billion and 9 to the power of a billion plus 4 are probably not going to make a lot of difference? And that's kind of the reasoning behind that. Do you recognize that as a geometric series? What is the common ratio going to be for that guy? I hear your mouth. And Tessa was right, because I could read her lips. It was 7/9. Is that going to converge then?
No.
Right. 7/9 less than 1? Yeah. Less than 1. It's going to converge. So don't I just need to check that the ratio, the limit is n tends to infinity of an over bn? Don't I need to check that that is a number? And if it is, we're good to go. We can now say that it converges. So I'm going to find the limit as n tends to infinity of an over bn. This guy is an, this guy is bn. So it's going to be the limit as n tends to infinity of an divided by bn. You almost always get in these questions fraction over fraction, right? They tend to be, most questions tend to be fractions. So that means typically your first line of algebra is to take the top guy and then do this guy on the bottom. And things are going to get ugly before they get pretty. If you multiply this guy and this guy together, you get 63 to the power of n. If you multiply this guy with that guy, you get 5 times 7 to the n plus 63 to the power of n.
Can't you cancel the 7 to the ends?
Oh, you made my life 10 times easier. Yes. What I just wrote there would actually work, but I would have made my life 10 times harder. So why don't we do what you just said? By the way, what I was about to do with this one is divide top and bottom by 63 at the end, so it would have came out, but this is much nicer. I am going to find the limit to this fella as n tends to infinity. 2 ways I can do it. Can you trust me that you can do L'Hopital on it and the answer ends up being 1? Okay. Or I could divide the top and bottom by 9 over n. What do I get? I get the limit as n tends to infinity of 1. This guy becomes that fella. This guy becomes 1. Now, if I brute force it, isn't 4 over 9 to the power of infinity 4 over infinity, and 4 over infinity is 0? So why don't I just cut to the chase? Didn't we get a limit that is equal to a number? In this case, the number is 1. And so, conclusion time, this series converges. And we should say by comparison test, but it's pretty obvious it is. The comparison test is going to cause you the greatest amount of work. They are the longest to do because of all this stuff, right? You're going to have to fight your way through a whole sequence of algebra just to get to the point where the limit is a number. And once the limit is a number, you can then say, my guy in the comparison behaved the same. This guy, I know it converges, so my guy must converge as well.
Wait, so
Yes.
when you take the limit at the very end, and you brute force it on the last step, wouldn't 4 over 9 to the n, wouldn't that, like, the denominator approaches, is that 0?
Yeah.
Oh wait, no, I'm just thinking of it weird. Never mind.
We're good? Right, it is. It works fine.
So for this one,
Mhm.
Isn't a to the n always smaller than b to the n? So why do we have to do the limit comparison?
Oh, because there's another test called direct comparison. Yes. And I think I said at the beginning, you can use, in some questions, can't use both techniques. I'm picking that one because the limit comparison test is, believe it or not, relatively straightforward. So you pick Well, I'm trying to pick some questions where I can give you experience of that. But yes, you are right. The comparison test will do that one really nicely.
Okay, just wanted to make sure. Thank you.
No problem. This is my second limit comparison test guy. That's our guy. Okay, now we have to figure out who to compare him against. Okay, let's do the surgery. If I wanted to do a limit comparison test, would you agree that this guy should be, can't really simplify him, cube root is a cube root. Give me a better way to simplify this fella. What would this be if you wrote it down in a much simpler version? Right, one that behaves like it, not algebraically the same as it, but one that behaves like it. What would this become? For huge values of k, like a billion, 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 wouldn't this behave like that? So when you're doing the comparison, when you're doing the surgery part, you should only try and have one term in the top and one term in the bottom. So you should never have k cubed plus 1 or k cubed plus 5k. Just have k cubed, right? Just have the biggest power, in this case, k cubed. Now, this fella on the top is a third. And this fella on the bottom is 3/2. Still with me? Now, when you put this guy and this guy together, don't you get 1 over, try to get my calculator here, 3/2 take away a third. And I'm going to turn that into a fraction. And it's k to the 7/6. Do you recognize that as a p-series? And the p-value is 7/6. And isn't 7/6 bigger than 1? And if the p-value is bigger than 1, do you converge or do you diverge?
Converge.
Okay, so I know, provided everything else remains the same, that won't this one also converge, provided I can prove the limit as an over bn is a number. Agreed? So, the limit as n tends to infinity of an, which is this guy, divided by bn, I'm just going to leave bn like this. Now that becomes the limit as n tends to infinity of the cube root of k over the square root of some ugly stuff times that fraction. And let's see what we can do with some killing. Won't that guy kill that guy off? And the limit as n tends to infinity becomes that guy. And then I'm going to notice that since both of them are a square root, that I can do that guy. Okay, let's finish this one off quickly. Can't you find the limit of the inside, which is 1, and the square root of 1 gets you 1, Are you happy about the limit of that being 1? Find the limit of the fraction and then take the square root there. And you can find the limit of k cubed over k cubed plus 5k plus 4. You can do that by L'Hopital's rule, or you can divide top and bottom by k cubed. I just don't want to do the next 4 lines because we've got a time issue. Now, since this is a number and the comparison one converges, can't we now do this one converges? Unfortunately, well, for me, I think it's unfortunate, you might not. When you look at these questions in the homework, you only have 2 buttons. So they don't ask you to show anything. They just ask for the answer. And you could, since you get 5 guesses, guess the first one and it's wrong, and then you guess the second one and it'll be right, you know, depending on the question. And that is bad idea. Will you do your homework really quickly? Yes. Will you learn anything? Not really. So you gotta have to fight through the algebra, because when you get your test 1, coming up in a week and a bit, aren't you going to have to do the proof? I'm not going to give you any points for you just saying, if I give you a question, does this converge or not? Which I probably will, right? Something like that. You can't just say it converges and expect to get 20 points. I mean, think about it. Who would give you 20% of the grade because you can guess well? Right? If I don't see working, you're getting nothing. And so if you don't practice showing me the working, you're not going to be able to do it. So that's my little spiel for you. Okay, so let's return back to these questions. And this time, I'm just going to do 1 more of these darn ones. And then we're going to, yes.
Sorry, I had a quick question. This might be kind of a stupid question, but
I like stupid questions because they're not stupid. Just my answers are stupid. That's
this one might be stupid. So I had a teacher that I think gave us multiple chances on tests to get it right. Is that a thing on your tests?
No, no, you do it. Well, you do it once, and if you don't like it, you could do the question a second time. I guess that's, but you won't know. I only get 1 answer from you, and you'll know later whether it's the right answer or not. So don't give me 3 versions and say, pick which one's right, because I won't do that. I wouldn't want someone to build a bridge and say, I've built 3 bridges here. Which one do you want to drive over? I don't feel that I want to live my... you lot are going to be some of you lot are going to be building bridges that I'm going to be driving on. And I don't want to risk it on the fact that you can guess well. So you're going to have to do it the hard way, I guess. Right, let's pick another horrible one. I don't really matter which one, they're all equally bad. Yeah, let's do this one. It's as good as any. So this is the last one that I'm going to be doing using the limit comparison test. Right, that's my sigma AN. Now we have to do the sigma BN guy, right? This fella needs to get simplified, right? So let's see what he simplifies down to. You can't really do anything with the number. So why don't we just call it 9, right? Can't simplify 9. It's already pretty simple. What could you simplify the square root of n squared plus 1 into? Do some surgery on it. Surgery means cut bits off and just leave the big bit. You may say something to us about get cut off.
Square root of n squared.
Isn't that just the same thing as 9 over n? Do you recognize it's a p series, right? They're all going to end up being p series or geometric, right? One or the other. In this case, isn't it n equals 1? It's actually the harmonic series, but that's just a special version of the p series. And isn't that guy less than or equal to 1? And so doesn't that one diverge? So if I've picked a good comparison series, won't this one diverge? Right, let's check it out. The limit as n tends to infinity of an over bn better be a number. Any number as long as it's not 0 or infinity. So the top guy looks like this, and the bottom guy looks like this. And now we have top guy, bottom guy. Well, I'll cancel the 9s. Oh God, I'm trying to think. There are at least 3 different ways right now my brain is telling me that I can solve that. Give me any technique you could use to figure out what that is equal to. The answer is going to be 1, by the way. Any technique for solving that. Oh, that's not good news. I can think 3 and nobody's willing to even chuck in 1.
L'Hopital's?
That would be the most natural one to do. And most times it's the right one to do. I don't do L'Hopital when square roots are involved. It's a personal thing and there's a good reason for it. Do you know when you do derivatives of square roots, doesn't the answer just become uglier? And the whole idea of L'Hopital is the top and bottom gets nicer. Well, the top does get nicer. The top's 1, but won't the bottom be absolutely horrendous because it's a chain rule? You actually just end up with an answer that a limit that looks just like your original. Not a bad thought process, Rosie. And most of the time that would have been a good choice. Okay. How about divide the top and bottom by n, but not call the bottom one n, call it n squared, which is the same thing. Okay, that's going to be the limit. 1 on the top, square root of 1 plus 1 over n squared on the bottom. Can we then just brute force it and get 1? Maybe you lot are shy, or maybe you lot don't like being wrong. Some of the best things I've ever learned in life were because I did something stupid and I learned from it. I like learning, so I don't mind being wrong. I get all sorts of things wrong. But as long as I figure out, oh, okay, don't use L'Hopital when there's square roots. I tried it once and I didn't like how it ended up. But see, I had to try it once, didn't I, to figure it out? I had to get it wrong at least once. Actually, with me, I had to get it wrong about 3 or 4 times before I finally decided, okay, don't do L'Hopital when you do square roots. It never ended well. I'm not going to waste my time doing that. Let's figure out another way of doing it. And that's how you learn things, right? So, yeah, chuck out the wrong answer. That's good. I'll just say, nope, that one doesn't work. No biggie. You know, I'll make more mistakes than you'll ever make. So let's look at this new guy, the new method. It's direct comparison test. Essentially, it's a little bit harder to write, although it's a lot easier to understand. I'll tell you what I mean. Suppose you've got your original and you've got a comparison test, right? So you've got the original, you've got your comparison. Now, if the comparison test converges, this is important. If the comparison is a converger, it'll be a P series, it'll be a geometric, just like before, right? If it converges and the following is true. Logically, why, if the individual terms of this one are always smaller than or equal than the comparison one, why by logic does it mean then that we can say quite safely that the original will also converge? What do you think the logic behind that sentence is? Why does it work?
because if you're adding up a sequence, or not,
yeah, adding up a sequence gets you a series, right?
yeah,
So
if
you're
you're adding up a
adding up.
sequence, and it's going to converge,
Mhm.
right? And the terms are a certain size.
Right.
If you just decrease those terms by a little bit, the original one still converged. All it can do is just be smaller, so it'll still converge.
I like the way you said it. I'm not going to change it at all. Yep.
Do you need an absolute value in that though?
We tend to make sure everybody's positive just to avoid the downtime.
Okay.
That's the easy way around to do it, right? I mean, you can adapt it if the answer's negative, but all you do is suck the negative out and pretend it's not there. So just think of it as always being positive, and that's good. Now, suppose you have, because there's two versions of this one, and let's say this time the comparison is a diverge. And that's true. Then you can make the conclusion that the original diverges. Would you agree that's the same kind of logic as the top? If all these guys are a little bit bigger than this fella, won't when you add them up, it's going to be an answer bigger than this guy? And if this guy diverges, right, he's infinite, won't this guy have to be infinite plus a bit more, so he's guaranteed to also be infinite? So what does that mean? If you're smaller than a converger, you converge. If you're bigger than a diverger, you diverge. Does the logic of that kind of make sense of why this test works? So let's pick some series and test out that theory. Here is one of these guys. That's my AN guy. The surgery part is the same in both methods. So when I talk about surgery, what I mean is you go to the top and you cut off everything and leave behind the big bit. And you cut off everything and you leave behind the big bit. Do you see that that becomes this fella? Are you happy that this guy behaves like a 1 over n to the 8? 1 over n to the 8 is a p series. That's p equals 8. That's bigger than 1, so that makes this series converges. Now, is it true that n plus 1 over this guy is in fact smaller than this fellow? Because if it's true, then you can, you notice that I've not done the n to the 8, I've kind of written it in the unfixed form. I think that's helpful. If it's true, then you can immediately say this guy converges, and it's a lot quicker. But if it's not true, then you have to tweak it to make it true. So here is where it gets a little bit messy. Let's start with that guy. If you remove if you remove an n from the bottom, won't that bottom term be smaller? Right? Agreed? And if you have a fraction with a smaller term on the bottom, isn't that guy going to be bigger? Right, show it me. If you take 1/7 and you knock 1 off it, isn't 1/6 bigger than 1/7? So that means I have a problem here. So how do I fix it? I do that. Would you agree 2n to the 9 is bigger than n to the 9? So 2n to the 9, right? Oops, my apologies. Don't know what the 2 came from, my brain's thinking. Would you agree that that guy is bigger than that guy? Now, suppose you have a fraction like 3/4. If you remove 1 from the top, doesn't it become smaller? And if you have 3/4, well, quarters is probably by choice now, and you add one, it gets bigger. So what does that mean that I'm going to do? Well, I'm going to take this guy. I've already said that that's true. And I'm going to double that. That's where the 2 that my brain was thinking about. And this fella is actually the comparison fella. And now we can say it converges. It's very easy for people just to do the comparison and get the answer. The proof of it can sometimes be niggly. Can you see that it's not obvious what this guy turns into here? Did you notice in this case, I needed to add a 2 to make it true? That's why limit comparison test has one advantage. In the limit comparison test, you don't need to worry about that. Can't you just compare it to this guy and let the limits take care of the set? So that's one small advantage. Try this guy. Suppose I wanted to do this fella. Sine squared n over n cubed. Would you agree that he's less than or equal to 1 over n cubed? Great. Isn't 1 over n cubed a p-series? P-series 3 greater than 1, it converges. Do you see how easy that one was to do? Sometimes the direct comparison test can be virtually obvious. Let's try. Who shall I pick? Oh, here's a really good one. Oh, sorry. Let's do this guy. Would you agree that 1 over n to the power of n is less than or equal to 1 over n squared? Pick a number like 5, right? 1 over 5 to the 5 is definitely huge, right? 1 over a huge number, but the whole thing is definitely small. So, guess what? Then isn't this true? And by the direct comparison test, P is 2, converges. When the direct comparison test works, it's really smooth. When you get a series like the first one I did, wasn't it much harder to prove what you needed to prove? But in a lot of questions, can't it be quite easy to prove what you need to prove? And you might think, why did you pick n squared? Well, I picked it because I wanted to. Because isn't that also true? And doesn't it still converge? How about this one? Okay, here's the guy to start with. First thing you need to do is decide whether this is going to converge or diverge. This one is going to diverge. How do I know it's going to diverge? Because that's important for what's about to happen next. How do I know this is going to diverge?
If you separate the, sorry, it's not separate, but if you do n to the 3 halves, it's going to be less than, no, greater than 1. I don't know. I think I just messed it up.
Okay, but you were thinking. That's good. Doesn't this guy behave like a 9 over n? 9 over the square root of n squared. So that's where I think your brain was. You just didn't like express it the way you wanted to, right? It's 9 over n. Now, I know that diverges. That means I got to keep this guy bigger than the next guy. Would you agree that this guy is bigger than that guy? Great. And isn't this guy bigger than that guy? What is he? Well, try a number like 5. Yes, he is. And isn't this guy a p-series that could diverges? My guy is bigger than a p-series that diverges. My guy diverges. You see, the method is a little bit clunkier this time. It wasn't as clean. But you start with somebody and you figure out a way to get to here, but always making sure that you keep the next guy, right, bigger than the previous one, right? So the next guy, less. How about this one? If I want to know who he behaves like, doesn't he behave like this guy? So don't I already know that the answer to this is going to be converging because he behaves like this fella? Now, since I know that, I'm going to start with this fella. And I am going to make sure that this guy goes that way, right? So this fella, this guy has to be bigger than him. Well, if you want to be bigger than him, how about that? And the next one has to be even bigger than that guy. How about that? And that guy is a p-series that converges. And since my guy is less than a converger, my guy converges. You got to be able to deal with fractions. Now, if you want to make a fraction bigger, right? If you want to take this guy and make somebody bigger than him, there are 2 ways to do it. Can't you double the top number or reduce the bottom number? You see, in this case, I doubled the top number, right? I doubled in n. Now, if you want to make a fraction bigger, there's another way to do it. Can't you make the thing on the bottom smaller? Do you see smaller? Makes the fraction bigger. I might say counterintuitive to you, but if you make the bottom term, the denominator smaller, won't the new fraction be a bigger fraction than the one you started with? So think about doubling things or taking things away, right? Doubling things or taking things away. And that's how you kind of go from left to right. Okay, let's try another one. 15. The guy that we're going to be looking at is this guy, right? You could definitely do this one, by the way, with a limit comparison test as well. Let's see who he behaves like. I always do the who he behaves bit, right? So I know whether I'm looking at a converger or a diverger, because that tells me where, what direction to do my working in. Would you agree that guy is an n over an n cubed? So it behaves like that guy. That just tells me that it's a p-series that converges. So if I know this fella is going to converge, don't I want a whole sequence of ones that look like that? Now that means that this guy is bigger than that one. Okay, so if you want this guy to be bigger, how about doubling the top? 2n is bigger than n plus 7. Would you agree for most values n? Pick 1,000,000 just to be safe, right? Isn't 2 million bigger than 1,000,007? Okay, I want to make this guy bigger than him. Well, can't you make them bigger by making the bottom smaller? How about making the bottom n cubed? Now, when you do the cancelling, guess I would need an equals there. Do you see I've now got a P series that converges, so my guy converges. I know I'm zooming through these, but the more I get, the better. How about this ugly looking guy? Converges or diverges? You should be able to tell just looking. Do you think that's going to converge or diverge? It must do one or the other.
Converge?
Yeah. The n squared in the bottom's a kind of giveaway. Do you think the sign of n is going to really do any big damage? Is it going to make answers really big? Nah. Right. So I know it's going to converge. So when I know it's going to be a converge, which seems to be the popular answer today, aren't we going to be doing one of those guys? Okay, guy in the middle, next step. I want to take this guy and put somebody who's bigger than him, and at the same time, not just bigger than him, right, but nicer looking. 8 plus sin n. How about 9? How can I get away with that? Because it's true. How can 8 plus sin n, right? How come 9 can be bigger than? It's the logic I used. Okay, what's the biggest number sin n can be?
1.
So isn't 8 plus 1 9? So that means it has to be less than or equal to 9. There's my logic. Do you recognize that guy as a P series? N equals 2 converges. P equals 2, I should say, converges. If you get good at the algebra, won't this method, right, the direct comparison test, be much quicker than the limit one, right, the AN over BN and doing all that stuff? I'm zooming around here. How about this one? Oops, wrote it wrong. Still wrote it wrong. God, I'm getting bad. It's not easy when they do subscripts in this fella. Who does that guy behave like?
Ten over n.
Okay, isn't 10 over n a P series? P equals 1 diverges. Right. You could do that one if you work at it, at least. Wouldn't 1 over n be negligible after a while? Wouldn't it be like 1 in 1 million, right? 1 in 1 trillion. It could be. Oh, since this is diverging, don't we want to go in that direction then, right? I'll keep the 10. I don't have a problem with the 10. How about this guy in the bottom? Couldn't we just do a 2 in there just to be on the safe side? And isn't that just 5 over n? It diverges. Let's pick another guy. Any shorty examples? Okay, time for one more. So, okay. That's got a video. I don't want the videos. You can do video ones yourself. Okay. Whoa. I wish I hadn't seen this one. Here's question 9. 6k take away 1. K squared take away 1 over k plus 1, k squared plus 3 squared. I first have to decide if this is converging or diverging, because that is going to make a big difference to what comes next. And the way that I decide converging or diverging is my little surgery thing. Do you know that guy there? I'm just going to call him 6k. That guy there, I'm going to call him k squared. That guy I'm going to call k. And this guy I'm going to call k squared squared. So the top is going to be 6k cubed, and the bottom is going to be k to the 5. Oh, do you see that it's a p series and it's going to converge? That's how I decided converging. Now, if it's going to be converging, doesn't that mean we have to go this way? So I want to write a fraction that's bigger than this guy, right? Bigger than this guy, but nicer, right? So what's bigger than 6k minus 1? How about 7k? What's bigger than k squared? How about k squared? Would you agree that's bigger than k squared minus 1? Now on the bottom, because I want this fraction to be bigger, don't I want these guys to be a little bit smaller? Because smaller on the bottom makes the fraction bigger. So smaller than this guy gets me k, smaller than this guy gets me k squared squared. So I now have 7k cubed over k to the 5. I now have 7 over k squared. Guess what? P series, p equals 2, it converges. Kind of quick, but are you comfortable with the process of what we did? Trust me, do you want to do the limit comparison test with that guy? No way do you even want to go there, right? Could it be done? Sure, it would work. Is it this cleaner, even if it does involve a little bit of algebra that you're not comfortable with because you haven't done it a lot? Anyway, you would say p equals 2, which is greater than 1. Your guy converges. Right, will you say your last name, space, first name?